Good morning and happy Republic Day. How are you, Saurabh?
Fine, ma'am.
This is absolutely insane, isn't it? Engaging in extra class on Republic Day. Yes, no? Saurabh, no comments? Well, I wish to finish this topic helical gears today. We'll complete this problem which we started in the last class and then we'll solve one more quick problem. So next class we can start with worm and worm wheel. Okay, 50 is a good number. Let's start. Quick recap of what we already discussed in the last class. Yeah, this is our problem statement. So this is a problem on a double reduction gear reducer with a shaft A carrying a pinion, shaft B carrying two gears 3 and 4 and shaft C carrying another gear number 5. Power available at shaft A is 5.5 kilowatt rotating at 960 rpm with an electric motor. Gears 2 and 3, number of teeth, helix angle, pressure angle is given. Similarly for gear 4 and 5, helix angle, pressure angle and number of teeth are given. Service condition says that it is on continuous duty and you have to also calculate what is the thrust at the shaft B. What is thrust? If you want to calculate thrust, what is thrust? Manas? Dhanush? Am I audible, boys? Pushparaj?
Yes, ma'am.
What do you mean by thrust? You have to calculate thrust at the shaft B.
Ma'am, thrust is the perpendicular force.
Yeah, perpendicular to what?
To shaft.
Perpendicular to the shaft?
I don't know, ma'am.
Who can tell me? Shantanu, you are there? 87?
Yes, ma'am.
What do you mean by thrust?
That only perpendicular force on the shaft.
What is perpendicular force on the shaft? Is that the radial force? Rishabh,
Ma'am, radial force on the face perpendicular to the face. Sorry, force perpendicular to the face of the shaft, maybe. I'm not sure.
perpendicular to the face of the shaft, which means what?
Radial force.
Which means radial force.
Yeah.
Perpendicular to the face of the shaft. Isn't that axial force?
Yeah. Oh, sorry. Right.
What, sorry? Yeah, come on, say it again. What do you mean by thrust?
Now I'm not. Now I don't know.
Abhijit,
Parallel to the shaft, maybe.
parallel to the shaft, yes, which is axial force, which is produced only in case of helical gear, or that undesirable thrust or the undesirable force which is coming because of the helix angle, that is Fa. And what is the relationship between Fa and Ft? Sai Krishna, number 73.
Yes, ma'am.
What is the relationship between axial force and the force Ft?
Fa minus Ft tan alpha.
Fa minus Ft?
Tan alpha.
Is it Fa minus Ft tan alpha? Could you please repeat once, Sai Krishna?
Fa. Sorry, ma'am. Tan alpha is equal to Fa by Ft. So Fa
Yes.
equal to Ft tan alpha, ma'am.
Right. So we know the value of Ft, so we can get the value of Fa. So a quick recap. We know the speed of the shaft A is 960. Speed of the shaft B is depending upon the number of gears on number of teeth on gears 2 and 3. We got B as 248. Similarly, speed of the shaft C is 110. From the design data book, we got the value of design power, which is rated power, multiplied by the service factors. We have assumed continuous duty and lubrication we have assumed probably as oil bath, for which we got the design power as 9.5 kilowatt. Then when we start with the design by assuming the module, in case of helical gear, we assume the normal module as Mn in millimeters. So now the pitch circle diameter of the gear is always 14 into mt, where mt is the module along the transverse pitch. So diameter is always taken on this plane. So it is always t times mt. And then we convert this mt in terms of mn. So this is mn by cos of alpha, where alpha is the helix angle. We get Vp also in terms of Mn and Ft in terms of Mn, because this force responsible for power transmission is power upon the peripheral velocity. Next step is we select the material for pinion and gear, and normally we select the pinion as the harder of the two, unless it is already given in the problem. So whenever you are to select, we will select pinion which is harder. Now here the difference of the value of S0 was huge, and so when we calculated the value of Y and S0 into Y, we got the value of S0 into Y for gear to be less than that of pinion. For calculating the Lewis form factor, we are using this formula, where this is the formula for a spur gear, not for a helical gear. And to make it a spur gear equivalent, what we do is whatever number of teeth are given in the helical gear, we divide it by cos cube of alpha. And this is the formative number of teeth, which is the helical gear is equivalent to a spur gear with number of teeth. Here it is assumed as 14, and this comes out to be almost 21. So a helical gear with 14 teeth is equivalent to a spur gear of approximately 21 teeth. This is the meaning of formative number of teeth. And the reason being, the teeth are inclined at an helix angle alpha. So this is how we calculate the Lewis form factor for pinion and gear. And we have seen in this case S0 into Y for gear is less than S0 into Y for pinion. And so we start the design of gear. Design is based on gear. So we'll take the pitch circle diameter for the gear, number of teeth into MT, where MT is again Mn by cos alpha. Mn remains the same for any pair of meshing gear. We calculate Vp, we calculate Ft. Ft will be same for gear and pinion. Next step is we go for the beam strength. Beam strength formula as per the Lewis form. Lewis equation is S0 YB Mn into Cv, as you know. Cv is based on Vp, but since Vp is not known, it is in terms of Mn. So initially we select the value of Cv based on its RPM. We know that this gear is rotating at 248 RPM, which is less than 1000 RPM. So we have assumed Cv value as 0.5, which means for a helical gear mounted on a shaft rotating at an RPM less than 1000, the beam strength is taken half of the original, and this is to compensate for the dynamic load or for the incremental load, which is not known. And we get the value of FB as 680 Mn square, which we equate with Ft. And for the value of B for helical gear, this is the range given in the design data book. In terms of MT and tan alpha, we'll convert this into Mn and sin alpha. So this range is always 4.5 times Mn by sin alpha to 20 times Mn by sin alpha. We can select any value in this range. You can go with 7.5, you can go with 12, you can go with 14, you can go with 18. But normally to use some default value, all of us will, for design, will assume it to be 12 times Mn by sin alpha, a value lying somewhere in between this range. And later we'll check that the value of B actual calculated is coming out to be greater than B minimum. We equate this Ft, the static load, with the beam strength. We find out what is the value of Mn, and we go with the next higher available value as per the preferred range of module. Once you get the value of module, this is the value of dP, Vp, calculate Cv from Vp, which comes out to be greater than our assumed value. So this is all the more better. From this value of Mn, we get the value of Ft. Now we will equate this Ft with Fb. S0 into Y remains the same. Value of Cv has changed. The calculated value is 0.64. Mn you have selected as 3 mm module. And B value is what we are going to calculate now. We want to make sure that the face width is greater than B minimum. So by this formula, B minimum is 27 and our face width we got by calculation is 35.8. So this is the first part. What next? What is the next step? Richa? We calculate the incremental load.
I'm calculating the incremental.
Yes. So let's start with this step. Find out what is FD. Refer the design data book for the formula for Fi. Here the incremental load is lesser than that of a spur gear because the operation is much smoother, and we multiply it with cos square of alpha. Refer page number 172 as per my data book, table 1611. Design data book, table 1611. Value of Fi is given. (21 times Vp). Vp is known. Take the value of C from the material. It is C multiplied by E, which is error. B, which is the face width. It is not the subscript. It is C into E into B. Cos square. Psi is the helix angle that we have taken as alpha. Plus Ft value you know. This is again multiplied with one more cos alpha term. In the denominator, it is 21 times Vp plus under root CEB square alpha plus FT. What is the value of C that we are taking? We have taken both the material as steel. So for steel and steel, what is the value of C? 20-degree full depth. Bharti. What is the value of C? Page number 16.4, table number 16.4, page number 167. It is 11800 as per the design data book. For steel and steel, we have taken both the material as forged steel. Error. What is the value of velocity that we obtained? 2.43, which lies in the commercially cut gear class 1. Give me the value of error. Give me the value of error. 0.045. We go with error as 0.045. Is it 0.05 or 0.045, Ambika? Ambika? It's 0.045. Give me the value of Fi. This is 3.910 cube. Use everything in newtons and consistent units. F should be in Newton. C and E, the values are given. B should be in millimeters. VP should be in meter per second. If you use FT in kilonewtons, your answer will be wrong. Omkar. Omkar. 77. Yeah, give me the value for Fi. What is the value? 6473. Others, please confirm. Omkar, I am waiting from you. Four nine nine seven. Atharva, this 6473 is FD value or FI value? FI. Why it's waiting? 374964. It's no variation. Four thousand 300, 3,700, 4,900, 6,400, 49. And now the two values are matching. Pranay and Manas are getting 4320. 4320. Karthik is also getting. Omkar is getting 3983. Aminia, you're getting 43. Aditya, Tanvi is getting 48. Yeah, one more answer, please. Let me go with 4320. Give me what is the value of FD, and this we compare with what? Give me the sum of this here. This is 8220 Newton. And this we are comparing with what? Prabhat? Prabhat Kumar? Prabhat Kumar is absent. Shantanu? Rakesh? Arshita? FB without CV. Give me the value of FB without CV, which is S0 Y B Mn. What is this value? We want this to be greater than 8220. Give me the value of FD. $1,000. How can that be 1,000? 10,000. Yes. Vineet, please check your answer. Are you getting this as 10,000? 9,429. This is good. All we want is this value of FB should be greater than FD. So our gear is safe in bending. What next? What is the next step? Harshita? Rushika?
Ma'am, we'll check for wear strength.
Yes. So what is the formula for FW? From the design data book, this is again modified for the helical gear. The wear strength would be greater. So this is K, which depends upon the hardness. B, which we know the diameter for the gear because we are designing for gear. The size factor Q upon cos square of alpha. So what do we normally do? Do we assume K and get FW? What do we do for this? Yash? We assume that this is safe and we equate this with FD and we find out what is the value of K. We equate this with FD. Now you can use your own values of FD. Somebody is getting 9,000, somebody is getting 10,000. So that depends upon to how many decimal places you are taking the value of cos square alpha or the under root value. So instead of 10,100, if you are getting 10,200 or 9,800, that is okay. But instead of 10,000, if you are getting 5,000 or 15,000, then that is not okay. Please check your calculations accordingly. Give me the value of K. And this should be the minimum value of the hardness. This is the minimum value of K which must be used. Is that 0.288? Shubham? Shubham, are you there with us? Point 288, 1.74. This much variation, Ayush, Shravya, Shubham. Shubham is absent. Now listen, for all the extra classes, I am not going to take your attendance. So if you are here attending the lecture, attend it. There is no point in simply logging in there's the link given and then you roam about. If you are here only for the sake of attendance. Aditya 109. 0.77, 1.74, 0.288. Oh my god, this much variation I cannot take. Somebody else please confirm. Is this such a difficult calculation? 0.76, Riddhima and 0.77. This seems to be matching. Riddhima, what's the value of your FD?
From 8220.
Okay, and FB is 10,000. So this value should be good. So this is the minimum value. We are assuming 0.768. Rishika, what is your value for K minimum?
Ma'am, I'm calculating.
Okay. Sushmita,
Yes, sir. I got
What is your value?
0.6.
0.6. Vaishnav is also getting 0.59. Saurabh is getting 0.57. Saurabh, Vaishnavi, what's your value for FD?
8220, ma'am.
Oh, it's same.
Ma'am,
Yes.
ma'am, should we consider the size factor as external gear or internal gear?
External. They are meshing externally.
Okay, ma'am.
What is doubt?
Ma'am, I'm getting 1.76.
1.72.
Yes, ma'am.
What is the value of B that you have taken?
35.8.
DP?
62.35.
DP. We are designing for gear.
Yes, ma'am.
So DP is 187, right?
Yes, ma'am, I took it wrong.
Harshini? Yes, 2.58. Your FD is 8220.
Yes, ma'am. And B is 35.8. And DP is 187.05. And Q is 1.588.
So with this data that Utkarsh is posting, 0.77 looks good. We have to see where is the error. अरे B27 नहीं लेना है, B is the calculated value of B. B27 is the B minimum. Our calculated value of B was 35.8, which is good, which is correct. 35.8. We just checked that this is greater than B minimum. Why you are taking B minimum? DP is DP decimal में. This is 54. How many number of teeth on this gear? 54 and 54 into 3. Mn is 3. What is the value of DP? Pitch circle diameter for? Oh, yeah, into cos phi. ठीक है, आया होगा decimal. And Q is 1.58. Alpha is given as 30 degrees. FD is 8220. So what is the final value of K? dP is 54 into MT. It's not into Mn, it is into MT. Okay, so we go with 0.58. 0.58. Now for this minimum value of K, what is the next value available for 20-degree full depth? Material is steel versus steel. Next to 0.58, next value is 0.721. And for K value as 0.721, what is the hardness? Hardness is 200 for gear and 250 for pinion. Hardness of gear is 200 BHN. BHN stands for what? What is BHN? Utticharan must have studied in Fresnel hardness number, yes. So what we have done is using this value of K minimum, it is 0.58 when FW becomes equal to FD. Now that value of K is increased from 0.58 to 0.721. FW value is definitely increased, and for this value of K, you are sure that FW is greater than FD. And so this is safe in wear. If in exam you have time, you can calculate FW, otherwise this is quite obvious. And the last step is to check for endurance. Find out what is the value of endurance. The value of SEB, this again depends upon the BHN. For the gear material, we are taking gear with 200 BHN, for which the value of SEB is 350 megapascals. (350 MPa) for 200 BHN gear, since our design is based on gear. So if endurance remains the same as that for, so per gear, we have already taken the value of Y, which is the equivalence per gear into Mn. Give me this and check if this is greater than FD. We'll take one more small numerical, which we should be in a position to finish in next 20 minutes.
Ma'am,
16. Yes.
I already rechecked, but FB without CV is actually coming out to be 6,000.
Sorry, I didn't get you.
Ma'am, FB without CV is coming out to be 6,000.
It's not 10,000.
If you could ask someone to recheck.
Yes. FB with CV was coming out to be this, right? 3.9, so it's almost 4 kilonewton. And without CV is 10 kilonewton. The value of CV is the calculated value. How much? 0.64. Yeah, somebody please check the value of FD without CV again. For the value of B as 35.8, Mn as 3, S0 and Y remains the same for gear. Now you are telling me, tab kyun nahi bataya? You are getting 6,000. So this is not safe. See, I don't have answers because every time we are taking different material. And so the answers are varying, and I am going largely by whatever values you are telling me. So 2 students gave me 10,000, and so we proceeded with 10,000. Now you are saying it is not 10, it is 6. You have to rework 6089. Now this won't be safe in bending. Now because this is not safe in bending, what do? We increase the value of B. Our maximum range is 20 times mn by sine alpha. So instead of 27, go for 15 times mn by sine alpha. Check what is the value. Increase the value of B, and when you increase the value of B, your FB increases. The value of Fi will also increase because there is B in both numerator and denominator. So go for the value of B. Now I can actually randomly increase this to 50 or 60, but then I should know that this is not going beyond the maximum limit or the maximum range. And so I am sticking it to 15 times mn by sine alpha. How much is this value? Okay, it is 90. Now with 90, give me what is the new value of FB without CV? FB without CV. S not Y, B, MN. Okay, so this is 15309. Give me Fi. We are solving it together so that whatever errors you are getting, you can ask me right now. If I simply go on solving with answers that I have, I'll never get to know what are your doubts. Now for the same value of B, check Fi again. Fi will also increase, FD will also increase, but the increase should be less than the increase in the value of FB. Vaishnavi is getting FD as 12,000 newtons. Now this looks safe. What is new Fi value, Vaishnavi? Earlier it was 4320. What is the new value?
8115.
8115.
Yeah.
Somebody please confirm. 8100 FI. Manas? Okay. So this is 8 and this is 4000. So this should be 12,000. 15,000 कैसे आ गया? अच्छा, this is FB. All of you are getting something around 8,000 Newton. Please confirm. FI is 7,000 for Pranav. Atharva Prajwal. Sushmita. So we should actually increase the value of B slowly from whatever is this value to 10 times of mn by sin alpha first, then 12, then 15. But again, need a lot of patience or a little programming so that you can do it quickly. 7,000. Shreya is also getting 7,000. 7,000. 7,000. Those are getting 7,000 some value. And so this value is either 12 kilonewton or others would be getting 11 point something. 11 point something kilonewton. Okay. 11. 10,900. It's 10.9 or 11. Now this is safe in bending. With the new value of B taken as 90 mm. This is safe in bending. With B as 35.8, this was not safe. You don't have to cancel this. You can always write with B as 35.8. FD value was coming out to be greater than FB without CV. Therefore, B is increased to 90 mm, still within the range. Now your beam strength is greater than the actual dynamic load. And so we say now this is safe in bending. And now everything would change. Since B has changed, the value of K will also change. This value of 90, you'll get different value of K. This value of K will also change. Value of BHN would change. And because BHN changes, this value will also change. I hope this part you can do on your own. I'll just dictate you another question and I want you to solve that question on your own. This would be a slightly simpler question. Should you go for next? Saurabh? Atharv? Okay. A helical gear speed reducer is to be used. A helical gear speed reducer is to be used with an 1800 RPM electric motor and a 450 RPM load. What is the type of load that is not specified, but it says 450 RPM load with moderate shocks. Moderate shocks. The 24 tooth pinion has 24 teeth, has a normal module of 3 mm. So this is a problem where module is given. Face width 40 mm, this is also given. Normal pressure angle is 20 degree and helix angle is 23 degrees. Both the gears, that is gear and pinion, they are made out of SAE 2320 steel with case hardening. With case hardening. Case hardening, the problem says the BHN is approximately 262. The value of BHN for the steel with case hardening is given. Estimate the power that can be transmitted for continuous duty. Moderate shock, continuous duty. Now this is not a design problem. This is like a conventional problem where the data is given and you have to simply solve to get what is the power it can transmit. And you have to check if the heat treatment is sufficient from wear point of view. If this heat treatment, that is case hardening, is sufficient from wear point of view, which means is it safe in wear? So we have the RPM given for the input shaft, we have RPM given for the output shaft, we have number of teeth given for pinion, so you can also calculate what is the number of teeth on the gear. Pressure angle is given, helix angle is given, face width is given, and module is given. Everything is given. So how to solve this problem? I want you to solve and give me the answers. You have to find out what is the pitch circle diameter for the pinion first. You will directly get the value. Peripheral velocity, you will directly get the value. From VP, you will get the value of CV also. S0 material is given. Value of Y, lowest form factor. From the formative number of teeth, then you will directly get the value of FB in newtons or kilonewtons. What next? यहाँ तक तो आप आ जाओगे. How will you calculate the power? If you reach till here, how will you calculate the power? Yes? Quickly somebody answer and then we can stop. Vineet, Utkarsh.
We assume that FB is equal to FT and we already know that FT is equal to design power divided by VP.
Perfect. So whatever value of FB you calculate, this will equate with FT. And if this is FT, you multiply this with VP and this will give you design power. And how do you get rated power then? We divide it by the service conditions, moderate factor, continuous duty, assume some lubrication factor, and that will give you the value of PR. That is the rated power. And similarly, you will find out what is FW for the given value of K, dB, B, Q, cos phi. And this, either you calculate FD from this data or you equate it with FB without CV. So while equating, you must get this wear strength greater than FB without CV, which is normally the FD value. If this is safe enough, then you say this is good. And if this is not, then you'll have to increase the hardness. So this much amount of heat treatment is not sufficient from wear point of view. This might be safe from bending, but not from wear. So this is how you solve a problem of different type. If you want, you can solve it now. Post the answers on the WhatsApp group if you want me to check. Else we can discuss this in the next class. But mostly in the next class, I want to start worm and worm wheel. So almost all the design problem of spur gear and helical gear would be of the same type. The data would be different. You are expected to get the value of M and B and then check for its wear strength, for dynamic load, for bending strength, and for endurance strength. Unless this part is clear, we cannot proceed with worm and worm wheel. So you please practice, take more problems from whatever book you are referring. Try to solve using the approach that we are discussing from the same BD Shivalkar design data book so that we are on the same page. Feel free to ask doubts if any. Anshuman? Anshuman, are you there? Roll number 123. Anshuman absent.
Yes, ma'am.
Okay, you are there?
Yes, ma'am.
Okay. You are there for the full class, right?
Yes, ma'am.
Okay. Aditya? Aditya Yadav? Hello, Aditya. Aditya seems to be busy somewhere. Sahil, any doubts? Abhijit? Rakesh? Say yes or no so that we can stop. Rakesh, no doubts? Okay. Should we stop here? The basic difference between second year to third year that you have grown is last year I was teaching second year theory of machines. If I give them a problem, please solve this and post the answer in the group. While I'm still to leave this meeting, they'll start posting. So that is the degree of enthusiasm in second year. In third year, it goes down to 50% and final year it is absolutely zero. So make sure it is not 50%. थोड़ा थोड़ा कम होगा, but इतना भी 50% मत करो. So if not all 71 who were present today, at least 40 to 50 students can post the answer if you have solved it. Please do that. Thank you. Thank you one and all.